teaching now, but you can contact with him by email.
Well, I tried and it didn't work. I would be really very grateful if you could contact me. If you think that this is of any value and has any connection with his ideas, we would really love to be able to get together with Maximo Sandin. I was very impressed with his ideas.
Yeah, I can talk with him and tell him what you are doing now.
Great, and see.
But I really think that what Maximo said don't fit with you are proposing now.
Because I'm too Darwinian.
Yeah.
Oh well.
And mutation rate didn't occur actually in nature. I think. There is not a fixed mutation rate.
Right. Punctuated equilibrium, right?
Yeah.
Is part of.
It's part of
Maximo's theory, right? Mm-hmm. Yeah. So you're saying he would just get furious if he.
But surely it will be interesting to the talk between you.
Yeah. Well, anyway, okay. So. Does this business of mutations, of very powerful mutations, did I understand that correctly, that viruses are the main mutational mechanism that Maximo thinks are driving evolution?
Yeah.
Okay, that I understood. That's good to know. And
right.
Is it possible how powerful are they? Can a virus make a big transformation in the DNA of an organism?
Yeah.
Or does it just insert itself in one place?
No. When viruses get inserted in genomes, not only import information from other organisms or from his own sequence, but viruses can make changes in genomes because some of the elements in the genomes are not just genes but mobile elements that can react from the environment conditions and the genome conditions. When a virus inserts in genomes, it can make a reaction in the genome that produce remodelation in the genome.
Wow.
Structural and functional from the regulation of the genetic information can change. The viruses have information for regulation of sequences. Excuse
regulatory
me,
genes.
my English is horrible, I know.
Yeah.
But there's information for promotion promoters of the genes, and other elements in the genes as insulators or sequences that regulates how the genes express into the genome and in the cell can change when viruses insert near a gene. So it's a powerful.
So Maximo thinks that in fact the major, how did he say? He calls them major transformations in evolution. But I guess Minor Smith calls them the major transitions in evolution. Can happen very quickly.
Yes.
Because of these viral viruses are very powerful. They can make really big changes.
Yeah.
Well, that strikes me that we have something in common. At least it's sort of interesting that based on his knowledge of biology, and here based on mathematical reasons, we're both. And you had an argument in favor of these mutations too, from a different direction.
Yeah, I think that there are genes that jump over from chromosome to chromosome globally.
Mobile elements can jump from chromosome to another.
Yeah, I don't know much biology, so. Okay, but that's encouraging, at least that part. Now, of course, I think if Maximo is 100% right, that everything in the, what is it called, the new synthesis or neo-Darwinism is all wrong, because I think he has a pretty complete theory to replace it.
Yeah.
Then I think this model dies, unfortunately, but maybe not, I don't know how much can be rescued. but at least there seems to be. When I first heard about his idea, I said, "Oh, I've wasted my time." but maybe does he think that some of Darwinism could be some of the old-fashioned mechanisms that the traditional evolutionists believe in could be taking place at the same time, or he really thinks it's only these new mechanisms?
Yeah, I think Maximo thinks there is nothing that can be rescued from new Darwin.
Okay, that's it then. Goodbye to this model. Okay, well, I think that's a very interesting question to see if anything can be salvaged from this approach. One of the things that can be salvaged maybe is the idea of a software organism. But then you have to have a model where it's horizontal gene transmission, and I don't know how to get a... But I'm going to be thinking about that. I've ordered all the books I could that Maximo has written, and one of them, the subtitle is Lamarckism or something?
Yeah.
Is that the right one?
In Spanish it's Lamarck y los mensajeros.
El subtítulo?
No, the main title.
The main title? Okay, is that the right book for an outsider?
Yeah. It's a small book and easy to read.
Okay. The book I ordered had that as the subtitle, but it wasn't such a small book. It's 300 pages. Well, I don't know. Anyway, I'm trying to...
Okay.
Yeah. Okay, so great. Thank you for those observations.
And do you have any idea of applying your model into a study for comparison with the real biology? So translating your mathematical model into a computer model, maybe...
What I did think about was how to get a computer model. To take a model, get a version of this that you could actually run on a computer, and you could do lots of runs, simulated evolution runs, and see what happens. But I haven't thought, but I think Professor Martin-Delgado, I think, thinks that would be a good thing to think about. And I would certainly, I wouldn't know how to go about doing it, but I would be delighted if some work in this direction was done. I haven't done anything, and those remarks I gave you are the whole.
That's what we are trying now.
What are you doing?
Yeah, we're trying to describe biological organisms in simulation models.
You're a biologist or you're a computer scientist?
No, I'm a computer scientist and he's a biologist.
You work on computer models of evolution?
Yeah.
And what are they
trying
like?
to get a tool in order to make comparisons with the real evolution and the archaeological history of fossils and things like that.
That's great.
And run
computer
simulations to compare both of them.
Right. I'm not aware of the work of your group, unfortunately, but I was aware of Tamara's Tierra. There's Avida, done at Caltech by Chris Adami. Is your model in any of those spirits?
We're still just beginning the work.
Well, I think it's a great project. Maybe we could combine our efforts, really, because I think it would really be good to exchange ideas and see what comes out. I think the part of this that I think is most central, and I would suspect will survive, is from von Neumann. It's the idea that what biology is really about is software. That's what gives biology its plasticity, its character. But then all the individual details of this model, especially if Maximo is right, but maybe so that's the part that I think maybe is most solid in this proposal.
I have one question. From the biological point of view, what is your opinion about artificial intelligence? How does it fit here?
Well, it doesn't fit. I mean, two things that are very important that don't fit in this model at all are the origin of life. Well, I can just make a few remarks that it's the origin of software, but that's it. This model assumes that life is already there. You've got a programming language, you've got DNA, you've got the expression of DNA when you run the program and see what it calculates. So you have basically life there already. All you're seeing is how it evolves. So this doesn't, the model starts with life there already. Now, there's nothing that corresponds here to to the brain or intelligence, as far as I can see. Or, you know, a very interesting question is consciousness, for example. So I think that's a fascinating subject, and I wish this had something to do with it, or I had some ideas that were different from this that were relevant. And I agree with you that it's an absolutely fundamental question, and how the brain works, for example, or what consciousness is, or do you have a mathematical definition of intelligence, and some, you know, maybe a proof that it evolves, or a proof that it doesn't evolve, or something. Yeah. But I don't know how to do that. But I think that would be a wonderful area to make progress in, if only we knew how. Yeah.
Okay. Any further question or?
Criticisms are okay too. Yeah.
He likes criticism. He loves.
That's how I learn something.
So let's thank our speaker.
Thank you. Thank you very much.